Hey everyone, welcome back. Happy New Year, and I hope January is off to a good start for you. Today we're going to be taking a look at GLSL Materials in TouchDesigner. Specifically, we're going to be rendering parametric curves by porting a Vertex and Fragment shader from a WebGL context to the TouchDesigner context. And through that process, we're going to learn a little bit about how GLSL materials work, how they are alike and different from similar constructs in WebGL land, and then use that knowledge to build this simple and hopefully pretty easy, cool little parametric curve renderer. And while we will be doing some GLSL work, it's not going to be so much writing new code as it is understanding the existing code that we're going to take a look at, and then understanding and kind of peeling back the layers with the TouchDesigner GL side of things so that we can understand what kind of translates and what needs to be translated by us. So let's first take a look at just kind of the effect that we're going to be working on. You can see here we have these parametric curves. They are animating in 3D space. We can kind of grow and have this color animation. We can change the animation speed. We can also define some parameters that will really let us warp these curves very easily. I think it'll be really nice to make that audio reactive. And then obviously we can change the density of our curves to kind of make it look more like a parametric surface, and numerous other things. So this is kind of to give you a sense of where we're going. And then all of this is basically going to be created with, this is basically just for the colors and for a little animation. So this is essentially doing all of the work of this entire effect. So all of that is in this single GLSL material, which is, you can see there, and that is going to be a vertex shader and a pixel shader. So without further ado, I think it's time to just get rid of these and start again. But actually, I guess maybe before I do that, I will go over to the original shaders that we're actually going to be porting, and this might give us a better idea of where we're going. So I linked to this in the YouTube description. I highly recommend that you go through and read this in depth before you continue with the tutorial. I'm going to go over it really briefly here, but it is going to be a lot more helpful, especially as we're talking about translating concepts, if you have a deep understanding of what the concepts actually are here. So I'm going to go through real quick, but like I said, I definitely recommend that you take some time, and it's not that long, so you'll be able to read it in 10 or 15 minutes probably. So here, again, kind of what we're going for. And you can open up this GitHub, and that's where we're going to go to get our actual shaders. So basically what we're doing here is building a tube geometry. He's using Three.js. We're going to use TouchDesigner. This tube geometry has some custom attributes, position and angle. And we can see here he's just using some JavaScript to basically set the attributes, angle, and position on the geometry. So this is one thing that we're going to have to figure out how to do in TouchDesigner world, because we don't really have the under the hood access that JavaScript and WebGL gives us to actually define attributes via code like this, or at least not easily. So we're going to want to try and do this in SOP world. I'm going to put a pin in that, and we'll come back to it. This is a bunch of stuff that is definitely worth reading, but not super important to our porting. Here, now we're getting into the Vertex shader and the Fragment shader, so this is important to us. The Frenet-Serret frame is kind of the equation that Matt is going to be using to calculate the curve in normal, tangent, and binormal. So you can Google that for some more information. You can start to see a simple demo as he's kind of building up to this Fragment Serret frame, which again, if we click on that, you can kind of see a little bit more about this methodology here. It's basically just a way for sampling a parametric curve to understand what the this coordinate system is going to be. So here there's a definition called create tube. This function, as he says, will actually extrude from a center line using the angle attribute and create a curve. So what's going on in here, basically we're going to be defining a parametric curve that will be a single one-dimensional in time line in three-dimensional space. And what we're going to do is use this create tube to basically, for every kind of ring like along the tube, extrude that away from the center to create a round tube similar to what we're looking at over here. I can make my thickness bigger and reduce my instances so it's a little bit clearer. Okay, so that's what this create tube function does. It will extrude, so we will be first using a parametric equation to define a line. Then this create tube will extrude that line into a tube, giving us most of what we want. And then this fragment shader basically is going to apply just some very simple diffuse lighting, kind of fake Phong lighting, using the normal that we calculated in the Vertex shader step by solving that Fragment Serret frame. So this is what will give us kind of this nice little shaded look, and it will do so pretty cheaply. So here, now he's going, and now we're using the sample function, which is basically going to be sampling our parametric curve. Now he's using a circle, turning it into a twist, and there we have kind of his final little torus shape. Now, this looks a lot closer to our final product. So he's taking multiple instances here. We obviously know that we can do that in TouchDesigner, but it will require us to do something a little bit different. So here it looks like he's then using the index, which I think will be our instance index, where he's calculating index, which will be from 0 to 1, and a result of mesh index over total meshes. So this will be our instance over total instances, and that will get us this little index, which he then uses to offset his parametric lookup. So that's what kind of gives you this nice little spread. They're modulating the per vertex volume, which will be something we can look at once this is implemented, but basically just making the line or the curve not consistently the same thickness. And then there's a little bit of additional information here that we don't need to go into. So, like I said, that was a really quick overview. I definitely recommend taking the time to read this fully, but that gives us enough information to understand how to port this. So the main things that we're going to be looking at, if we go over to his GitHub page and we go to the lib and shaders, we can see here we have our tube vertex shader and our tube fragment shader. Now, these are the two that we're going to need to port over to TouchDesigner. It's not quite copy and paste, but it's not really that much harder. It just takes a little bit of knowing what to replace and what to keep. So basically, right now, we're going to start just working through this port and just going through kind of debugging one by one. To do that, I'm going to try and keep this all in the frame if I can. And now I am just going to fully delete this. So I'll give ourselves a base, and we'll call this GLSL Mat Parametric Curve. Just like that. Get my bars back. So this toolbar, by the way, I can also put this link in the description, but this is the Function Store TouchDesigner toolbar. You can get it on GitHub because he is a legend and has open sourced. It's super handy. I use it all the time. So yeah, lots of cool stuff. Anyway, so first things first, we need to get our tube. Like I said, we don't have a 3-dot shader, or a 3-dot cylinder geometry to call to create this tube, so we have to do it inside TouchDesigner land using SOPs. Thankfully, there's a tube SOP, so that's pretty easy. Now, I think everybody's probably pretty familiar with what happens next. I'm just going to create a little render network. And actually, if you use the function TouchDesigner toolbar, there's some cool presets you can create. For example, you can have this render top just kind of drop down the full setup, and then you can just drag and drop this, and then boom, we have a tube and a renderer, and it's all already set up. But if you don't have that toolbar, and for those of you who may be doing this for the first time, we'll do it really quick. So I'm going to drop down a geometry. I'm going to drop down a light. I'm going to use a camera viewport. And then a render type. Just drop a null. And then after that, I will add I'll add a transform. Background comp, and then I like to make this just not black. Now we have an error on our render comp, and that's because we need to drop this camera viewport in there. And then we want to probably give ourselves some settings. Oops. So drag and drop, set reference expression on source, and then this button will open a toolbar. And this button will open the top level, so super top level project parameters. This button will open just the parent parameters, and then I'll just drag and drop that resolution. And so now we're all wired up there. Okay, so okay. Well, apologies for whatever just happened there. Somebody unplugged my external monitor, so everything kind of tweaked for a second. All right, so anyway, we have our tube, we have everything. Now we need to drop down a material so that we can actually start to port things over. So for that, I'm going to use a falling material, output the shader, and we just do this so that we have all of our kind of boilerplate stuff set up for us. Drag and drop the shader on there, and now this is kind of a framework that we can start to work in. So this tube will replace the cylinder geometry here, and we can go ahead and just take a quick look through the shader and then open it up and port it. So we have these attributes. So this is best to think of as information that's being passed from the geometry to the Vertex shader. We have these uniform matrices. So these will be built-in uniforms from 3JS that will basically pass information from the camera to the vertex shader. So we'll have to find a way to replace these. Uniforms, everyone should know about. Varying, this is a way to pass information from the vertex to the fragment shader. So we'll have to find a way to replace that. This GLSLify is a GLSL library for WebGL development. So that's basically just importing these functions that we can replace with our own. We have a spherical function that's just kind of like a utility. Further down here, we have our sample function. That's where he's sampling his parametric curve. This robust flag you can read about in his blog post. It doesn't really matter for our purposes. We have this function, create tube. That is the one that actually creates the tube from the line. And then we have our main function, which obviously does everything else. So I'm going to go ahead and open up our existing shader. And we'll get this over here. Okay. Sorry about that. Get this over here. And so, yes, this is what our vertex shader looks like right now. And basically, what I'm going to do is just go back to Chrome, copy this whole thing, and I'm going to basically just paste the entire thing right between this overt and our main function. Now, toggle autosave so that it is autosaving our geometry, and then not our geometry, so that it is autosaving our code rather. And now we can float our info window and really start to dive in. So, like I said, this is just pasted, so there's a ton of errors, and we're just going to go work through those errors now, kind of one by one. So, first things first, attribute is deprecated. So we said the attribute is just passing information from the geometry to the vertex shader. And if we go to his blog post, we remember that position and angle is, so position is a one-dimensional float along the x-axis in the range negative 0.5 to 0.5. And angle is a float in radians from minus pi to pi, telling us how far around the tube this is. So if we use a carve sop, and I give my tube some more height, we use a carve sop, and we turn all this on, we can see that we can actually use UV coordinates that are built in to the TouchDesigner geometry to replace this position and angle with very little effort. So our U and our V are basically going to take the position of this position and angle. So we can see that our U is what goes around the curve, and so that's this angle, which is radians telling us how far around the tube each vertex is. And then our V is the up and down, which is position, and that's the one-dimensional float along the x-axis, negative 0.5 to 0.5, telling us the distance of the vertex along the curve. So we can also see this by using a sop2dat and extracting vertices. We can see that these UV coordinates per vertex are all listed here. So here's our UVX that is equivalent to our angle, and that we can see is kind of looping around the curve, especially if we reduce the number of columns. We can now see that this UVX is looping around the curve, while UVY is just kind of increasing linearly. So that is our position and angle. So how do we replace those? We basically just get rid of all of those attributes. And now we can control F. We can control F angle. So the angle is getting passed into this function. Angle is getting passed into this function. Okay, so here is angle. We want to replace that. So here's two angles we need to replace. Now, how do we replace? To know what to replace with, we can go to write a GLSL material documentation by derivative. And this, as you can see, is extensive and has a ton of information about how you can replace things, or sorry, not replace things, has a ton of information about how GLSL shaders work inside of TouchDesigner. So there are a ton of built-in stuff that TouchDesigner gives you that allows you to kind of more easily work with geometry. So like I said, there's a ton of information here. You should definitely go and read it all if you're at all interested in working with this more extensively. But what we're looking for right now are these TouchDesigner specific uniforms and attributes. So these matrix uniforms we'll come back to. What we need right now is attributes. Yes, okay, so Vertex input attributes will be named the same as they are in the TouchDesigner SOP interface, P, N, and UV. So that's great. That means that, one, our SOP to DAT will tell us basically how we can also reference these attributes. And we know that we're getting the position, the normal, and the UV attribute from TouchDesigner built in. So what that means is that we can actually use instead of angle here, we can use a built-in uniform, UV. Now UV is an array because there can be multiple textures. So we take the first element of that array. There can be multiple layers of UV coordinates for texturing, I guess is a better way to say it. And we take the we take the X because this is our angle, which is our position around. Now, this is in the range 0 to 1, and it needs to be in the range -pi to pi. So I'm going to get rid of these imports while we're here because it's time for us to recreate with our own. So, oops, not that. I just want pi. So we just will copy pi to some digits, and then we will define our own pi. We will also define a quick little helper function that we'll call map, and that will take in floats, x, and then a, b, c, and d. And so A and B are going to be your min-max of range in, and C and D will be your min-max of range out. And then we will return C plus x minus A over B minus A times D minus C, which I'm sure is something everybody's pretty familiar with. And then we can use that map function down here to map our UVX from 0 to 1 to -pi to pi. And so here we are replacing angle with remapped UV coordinate. And then we'll just copy and paste that down here where we use angle again. And now what we have to do is replace position. And so we can define a float position, and that can be equal to UV. Again, we're grabbing the first layer, Y, and we want this to be between, so he's remapping already from minus 0.5 to 0.5 to 0 to 1, so this is already in the range 0 to 1, so that should be fine. Which means we can actually just say t equals position, because we don't need that remapping. Okay, so now we have successfully replaced our attributes. Let's just make sure there's nothing else using that position. There's not. Cool. So our next error, varying. Varying is also deprecated, and in this case, that doesn't mean deprecated. It means it's not used in TouchDesigner. So instead of this varying, TouchDesigner provides us with this struct, overt or ivert in the frag shader, and this is basically the TouchDesigner version of these varyings that pass information between the Vertex shader and Fragment shader. So we will need to basically just figure out what of these members or attributes for the structure will correspond to each of these varying vectors used in the WebGL code. So our normal will be pretty easy, so that will be v normal. And then these other two we're going to need to add. So I'm going to add a vec3 for my UV and a vec3 for my view position, and this will be v view position, and this will be our VUV. Now I'm gonna delete these, or I guess just comment them out, but that means we have to then replace all of this in our code. Now, you may have expected us to get some error like view position not defined because we just commented it out, but instead we got this kind of weird error, which is unexpected sample expecting comma or semicolon on line 67. So the reason that this is kind of weird is because in TouchDesigner it's expecting sample to be a reserved word, which means that we can't define our own function for it. So I'm going to use sample open parentheses and just replace that with parametric curve open parentheses and replace that everywhere. Now we don't have that weird error, and so we can go back to kind of replacing the rest of these. I guess there's still another uncaught, but that's fine. I want to kind of replace these while we are on this topic before continuing to go through those errors. So my view position, I'm replacing with this overt structure and the member view pose. So I will replace this with overt dot view pose, just like that. Used to be view position. And then I'll do the same with normal, but instead of view pose, we'll use world space norm. And then we'll say this used to be v normal, used to be VUV. Now this VUV will also look for, and we'll replace this only with the first two components of our overt.uv.xy. And now we can just kind of get rid of all of these. Okay, continuing on, now we have line 65, ease, no longer defined. Easing was, if you remember, one of these imported functions from the GLSL library, or yeah, whatever. One of these imported functions. This is an exponential in-out. You can either define that for yourself or just use a different easing function. So I'm just going to go up and define my own easing function. Define my own easing function, and then I'll do that with a float. I'll call it ease. It'll take in a float x, and in this case I'm just going to return a smooth step applied to x. So a very simple easing function. Okay, and now our error jumped up to line 184, which is great because it means we make some progress. So now we got to figure out what length segments means. Okay. Now we would think this should be something like a uniform probably. If we go to our parametric code and search for length segments, we see that Matt is using his length segments that's being set up as a define statement. So we could do that with like a preprocessed directive in our code, or we could just use a uniform for it. So we can use that uniform. U length segments. We'll go add that to our uniforms. Uniform float U length segments, and then we can replace length segments with our new uniform. Now in 185, so this is saying U-length segments is an undeclared identifier because I had a typo there. And now we can go to our next error, which is 229. By the way, in VS Code, Control-G will let you jump to a line. So 229, this says that cannot apply to an array. So here something a little bit weird is going on, or it looks a little bit weird anyway. So this says overt.uv.xy equals uv.yx. Now if you remember, this uv in his shader was actually an attribute that he's passing in. And what he's trying to do is basically pass, or if we go back here, what he's trying to do down in this line is basically pass the UV from the geometry to the fragment shader. So he's setting this varying equal to that attribute. So that's basically saying from the geometry to the vertex shader with the attribute, and then from the vertex shader to the fragment shader with this varying. We've done the geometry to the vertex shader with our TouchDesigner specific uniforms, and then we've done the vertex shader to the fragment shader with this overt struct. So all we need to do is replace this with actually the TouchDesigner specific uniform, which looks very similar. We just need to grab the first element of that array of uniforms, and that cleared up our error. So our next error is because we have two main functions. So I will get rid of this main function and get rid of that. So now we have just one big main function. And now we have successful compilation, but we have some errors linking to our fragment block. So we can fix that. The reason that that's happening is because you need to have identical data structures going out from the vertex shader and going in from, going out from the vertex shader and in to the fragment shader. But in the fragment shader, we use an in and we call it ivert. Cool, so we won't do anything else in the fragment shader right now. Just wanted to kind of get that working, and it is working, but not quite how we want it to yet. So there's a ton of uniforms that we need to assign, it looks like. And so we can start doing that. Give ourselves a bunch. And basically just port over. Now, see, this index I'm going to skip because we talked about when we were going through here. Index in Matt's world is a 0 to 1, which is mesh index over total meshes, which in TouchDesigner world is going to be instance over total instances. And that means that we're not going to define this uniform as a uniform. We're actually going to calculate that on the fly. So I'm just going to delete it. And then we'll go radial segments, and then we already have our U-length segments. So we can put some numbers here. Our rows should be our length segments, I think. And then our columns, unlock. Our columns will be our radial segments. Animate strength, animate radius, I'm going to leave at 1. Time, I'm going to, okay, so at this point I'm going to customize my component. Animate curve speed, I'm going to add just a simple float. Call it animate curve speed. And then what I'm going to do is use a parameter, grab that animate curve speed, then use a speed chop, then use a null, call it curve speed, and then I'll drag and drop that onto my time. And this will let us then control the time with this nice little speed, so we don't have to worry about using like apps time or whatever. I like to do this for all of my kind of translate based parameters. Okay, so that's real nice, but we are not quite there yet. Thickness, I also just remember that this has to be much, much smaller, so I'm just going to set it to something really small now. And we're back to having errors. So now index is an undeclared identifier because we just got rid of that that uniform. And so what we have to do is rewrite that uniform into our code somehow and calculate it on the fly. So in, again, match shader, he's using that index as an offset in this parametric curve lookup. So what I'm going to do is down here where we call this index, I'm going to define a new variable, and it'll be called index. And this is going to be equal to td instance ID. We know this from write a GLSL material. If you search for instancing, you can see, yes, instance ID can be grabbed with td instance ID. We don't actually have instancing turned on, so I'll turn instancing on and I'll use manual length. A right click on here will bring up this edit menu. So we'll add a number or a parameter for number of curves. We'll make it an integer. Add that. Let's make the range something like 100 maybe. And then we will drag that number of curves to a new uniform, unum instances. You'll notice that my uniforms, I'm using this U prefix. I like to do that. If I were doing this for a full project, I would probably be replacing all of these with like U thickness and U time for cohesion, but I'm not doing that here. So just a quick aside. Okay, so now we have our unum instances uniform. We can just add that to our shader. Float U num instances, and now we can go down to where our index definition is, and we'll basically just divide this TD instance ID by unum instances, and then we will have a index between 0 and 1 based on instance num. Now that's great, it takes care of this. But we still have this undefined instance issue, or sorry, undefined index rather, on line 72, which is in our parametric curve function. We can get rid of this by just passing that index variable through to the parametric curve function. And then we will just have to, Control F this, and make sure that we go through and add an index to it wherever this function is called. Now, since here it's being used inside of another function, we'll have to make sure that we pass an index argument to that function. And we'll just continue to go through. I'll add my index argument there. Here we're inside of a new function. So I'll create that new argument and then go ahead and add these. And now all we have to do is pass that create tube function the index variable that we just created, and now boom, we've taken care of all of those errors, and we're passing an instance level variable through our create tube, which means we'll have instance specific tubes. We're almost there, almost about to start seeing something cool. Bear with me. Now we have no compile errors. If I get rid of this, I'll get rid of this. We have no compile errors, we have some warnings, and that's that these matrices are not assigned. So remember, these are the matrices, the built-in ones that Matt is using in his shader. We need to find a TouchDesigner replacements for these, and I mentioned we would come back to those TD mats, and so that is what we'll be doing now. You can see here all of the matrices that TouchDesigner provides. So you basically just need to go through and understand which of these is going to be the right replacement for his matrices. So the projection matrix is actually the easiest because this TD world to proj function, that's a TouchDesigner built-in function, will actually do that deformation and the projection matrix for you. So we don't need that projection matrix at all. We can actually just delete this totally. And then we just have to, instead of deforming this with P, which is our geometry position attribute right from the SOP, we can use the transformed point position, which is what comes out of this create tube function, and we can pass that in instead. And now we can see that as soon as I did that, we have this, well, it's deformed at least. It's a little bit spiky right now, but we still have one or two matrices to fix. So projection matrix is now squared away, and we now only have two. We have the normal matrix and the model view matrix. So we go back to here. Now our model view matrix is just going to be, so we have our model view matrix and our normal matrix. So our model view matrix is going to be just this cam. And then our cam for normals will be the normal view matrix. So I'm gonna remove those, and now we'll get these errors where these matrices aren't defined, and we can just go and replace them with the reference to the appropriate TouchDesigner UTD mats. Again, this is an array, so we grab the first element, and then we do .cam. No, what's wrong here? Oh, this is the normal matrix, sorry. So this should be U, TD, mats, 0, cam for normals. And then the model view matrix will be U, TD, mats, again, 0, .cam. And so now we have pretty much successfully ported that entire Vertex shader, replaced everything we need to replace. We have all of the information coming in from our geometry, going out to the Fragment shader with the structure, using all of our uniforms. And now we can simply give ourselves some more rows and a couple more columns, maybe like 30 columns and maybe like 250 rows. And we can see now that we have a much smoother, more interesting looking curve. This might be a good point to just drag and drop some of these parameters. Give myself up to 500 rows, drag and drop those columns as well. You may want to have a thickness parameter, which can be a float. And I'll have it go from 0 to 1, but I know that I don't really want this to be any thicker than maybe like 0.1, 0.05 maybe, something like that. So I'm gonna actually just say 0.05 times parent.par.thickness, which will then let us start to, and we can actually do something like 0.001 plus. And that way, when our thickness is 0, we still have a really thin curve. We can give ourselves a lot more rows or columns, and you can see that the more rows that you use, the more obvious the modulation of the volume is around the rows. I'll go back down to 250. This will animate the curve speed more, and then we're noticing that giving ourselves more instances isn't working because we haven't drag and dropped this parameter. So now we can give ourselves more instances too and really start to see this curve come together. All right, so the last step here is going to be porting the Fragment shader. So we will open up the Fragment shader. We will go back to GitHub. We will simply copy. Similarly, I'm just gonna paste the whole thing right here. And we'll get rid of this extension and precision. We'll get rid of these varying since we know we don't need those. I'm gonna get rid of this, like 3. This color, I'm just gonna change it to U color right now so that we don't get confused. U color. We'll get rid of this GLSLify. And we'll get rid of our main function since we already have a main. And yeah, okay, so we get rid of the main function, and Now we can look at what our errors are. So on line 57, oh yes, there's this hashtag FFF. Not really sure what that is. I think it's like I'm not sure. It's some shorthand for WebGL, but I'm not familiar with it. So we're just going to replace that. I'm going to replace it right now with just a vec3 that's red. And then instead of having this color just pull in color from our geometry, I'm going to say multiply that color by the diffuse term that we're calculating from our lighting in the fragment shader that we're porting over. We have another error. This uniform is not allowed in nested scope. Okay, that's fair. We need to move these uniforms up and out of our main function. View position needs to be replaced with ivert.viewpose. VUV is replaced with ivert.uv. We'll mix just color RBG. And then we, actually can just say color equals diffuse times current color, and then we don't actually need this color times equals diffuse up here, and then we can just get rid of this GL frag color here. Assign just color.rgb, and then now we have a more well lit geometry. And if we add another light and move it around, we can see that we are getting some cool shading effects. So that is now pretty much fully done porting over this shader from WebGL to TouchDesigner. I'm going to get rid of these. Okay, so to now we probably want to like add our own color palette, and then maybe give ourselves a couple more ways to interact with this. So I guess first, see in the demo, a little demo, if you click on it, it'll like animate colors. That's kind of cool. So that is what this animate radius and animate speed will do. Or sorry, animate strength, rather. So for something easy, we can just use well, that happened again. Sorry. Okay, we can just use the middle button. Let's call that M. And I'll just use a lag and then a null. And then we can just drag and drop this on the animate radius. and the animate strength. And so now when I middle mouse button, we're just kind of cycling through this animation, and you can see the highlights come in. Now that highlight color is this. So now I just changed it to green, and so now it's animating in green. So we could, if you wanted to, add a parameter in here that's an RGB and call it transition, color, and then if we go into our shader code, and instead of this we use uColor, now we'll have this nice color palette that we can pick from, and then you could obviously like animate this parameter, or do whatever. Something really simple like RGB, give it a period that's like 0.02 or something, and the phase can be me.chan index divided by, I don't know, 5, just something. So now they're each on a little bit of a different phase, and then the amplitude can be 0.5 and the offset can be 0.5, and then I'll use an S curve and a null, and reference. So now we have this kind of animating color that will be the color that's used to transition between. So that's nice. You can obviously do a bunch of different interactions there, but I'm just going to be doing that. And then for color, so base color can be done a couple different ways. I think the easiest is probably to just use like a ramp. So we can, I don't know, find some ramp colors that we like. Those should be alpha full. Find some ramp colors. We're like purple, get some red, some blue, and we'll go back to some like purple. Maybe we don't need that orange. Okay, nice little ramp. And then we'll just call this color. So we'll make a quick sampler. We'll call it uColor map. And then we'll go in here, and now this is going to be in both our Fragment and, actually no, I think we can do this in just the Vertex shader, because we already have this color that we're passing through. So where do we set that? We set that right here. So we can just set this with some color that we look up. And we know an instance. And so we basically just need to translate this instance ID into some sort of like color lookup. And so we could just use the instance itself to look up a color based on, let's say, the X direction. So just do that up here. Vec3 color. 3. Lookup color, and then here we can do texture, S color map. We'll come back and fix this. .rgb. But we don't have this S color map right now. We have to add that as a uniform. Sampler 2D S color map. And now instead of, now instead of looking this up from a UV, we want to look it up with the instance index. And so we can do index and then 0.5. And then we can change this color to TD. We should probably make this a vec4. And then replace this with lookup color. That did not quite work. S color map is unassigned. S color map, not U color map. There we go. And so now that was pretty easy, right? And now we have this colors that are being looked up from our ramp. Obviously that could be a texture. Obviously it could be a number of different things. But we have now that color being looked up. Now, the last piece, I think, is kind of some cool permutations. And for that, we can go and actually start to mess around with the parametric curve itself. Now, I'm going to leave this as mostly an exercise to the readers, or viewers rather, to actually go through and do some parametric curve exploration. But something that we can test out pretty easily is just like changing some coefficients and seeing what happens. So for example, you can see that this coefficient changes the curve a little bit. This coefficient also changes the curve quite a bit. So we can add another uniform, and I'm just going to call this U curve distort. And we go back to our vertex shader. Uniform float U curve distort, except not a float. I want it to be a vec4. And then I'm basically just going to say add some coefficients, basically. Like for example, times beta times U curve distort dot x. And so now we're here, U curve distort dot x, and we can see that we can use this to then kind of cycle through some cool animations. Now, you can do that with a bunch of different parameters. You can go define your own curves. I'm not really going to keep going down that route, but that is how you would go and add those levels for yourself. Yeah, so I think that pretty much does it. We have a very nicely rendered little parametric curve here. We've got some parameters. We can change how many curves there are. We can change the thickness of those curves. We can change kind of their resolution, the animated speed, and don't forget we also have this transition when we middle mouse click. So hopefully that was a helpful overview, understanding how to kind of take GLSL Vertex and Fragment shaders from a WebGL context and port them into TouchDesigner. I think it's something that will allow for extending several techniques out there. If you have any questions, please let me know, and thank you for joining. It's always such a big support receiving all of the feedback and everything from the community, so I very much appreciate it. And with that, I will end things for today and look forward to speaking with everyone next time.